this is speech notes. It's recording speech notes or speech notes. So it's recording now. Is it recording? Are you recording? Yes, I am recording. Continue. Today's date is 27th of December 2025. Literally, still researching the world around me. I'm trying to research and everything. Literally, guys, this is only basically. This is basically the only reason why the main reason why the NSIGGI protocol literally just exists. Literally, it just exists because of this video. Basically, it reminds the world around the Napalm War, everything happening in Vietnam. Basically, napalm is not really a secret. I'm just gonna give you a secret because I know the secret. Napalm is made by basically sodium chloride. You get basically you get hydrochloric. You get think of it as hydrochloric stuff. This acidic, it's just acidic composition only. It's never alkaline. You can't even put it out alkaline because you have atomic structures in the napalm strike. But you know they are basically they're heterogeneous homogeneous because you can get alkaline in it, but it's only acidic. Napalm is acidic composition. It's like a fire, but fire is acidic. So basically, it's sodium chloride. Basically, that's the main one. But it comes with something else. Napalm is fire. Basically, napalm is when you get a napalm strike, you get everything goes in oxygen. But this just it becomes more acid. So there's more basically. The more oxygen you put in, the more acidic it becomes. That's how it works. Literally, it's not really too much, but it's composition of a lot of oxygen because oxygen can be oxygenate. I mean, if you condense oxygen enough into something, it can become into the chloride. Into this chloride, it becomes chlorine. Chlorine can become distilled into hydrochloric acid, and hydrochloric acid is what's literally just creates more fire, fuel, which is the liquid form of the sodium, and the sodium burns the fuel, which basically it distills sodium chloride, and that's NaCl. That's the composition of literally. That's the one thing from else. It's sticky and it burns you because it's sticky. It keeps burning because you're sticky. You can be stuck to. If you can't be stuck to, napalm will not be effective. But in napalm, apart from napalm, napalm strike is like if you're not sticky, if you don't have sticky surface, you are literally just repelling it, and you are putting it, you put it out eventually, but it'll take a lot of time because it burns with sulfur. Sulfur conversion is of sodium chloride, NaCl, hydrochloric acid, pH scale above 7, which is very important to understand. pH scale above 7, that's basically acidic compositions only. So water is neutral, acid is on, am I wrong? Okay, let me just check it. I think I'm wrong now. So basically, HCl, Na is sodium, but sodium chlorine is Cl. But sodium chloride is a power chlorine composition. It literally annoying me because sodium chlorine is literally the same thing as chloride. So because you get chlorine in the form of gas. But hydrochloric is only in the form of because it's very unstable because it reacts with water. It can be stilled by water. So the water is can be opposite of the obviously you get the double one for HCl obviously hydrochloric acid, not HCl what table of hydrochloric table of alkaline. Table of alkaline. So basically, alkaline is a metal. Alkaline metals are opposite of the pH scale. The pH scale is what? The pH scale. Why do you need the pH scale? That's what I'm trying to call it. But I'm trying to get this sorted out. But because I'm going to employ that weapon, basically, I'm trying to put out fire with water, but it's going to be opposite and stuff. pH scale is basically the most acidic is 214. Sorry, it's opposite. So yes, I'm right. So this is what I'm saying. It's acidic is 40. It's meant to be literally just acidic, but pH scale is less than 7. It's acidic, so it's not acidic that's there, but it's never alkaline. It's never has to react to alkaline. Alkaline, you can have basically this is what I'm saying. You get in napalm, basically you get sodium chlorine, chlorine square cubed. Cubed is the I think it's HCl, Cl chlorine, CH you got chlorine, that's a chlorine composition. But you get someone's basically keeps burning because you're sticky. You can be stuck to Cl. Yes, number 17. 17 is the atomic number. So basically NaCl. I was right. Basically, sodium chloride forms table salt chlorine. Basically, it wasn't kind of it's very effective because it's sticky. It can be. You guys know it can grow without it's stable. It's a stable isotope. That's like chlorine is a stable isotope. That's why it works really well. And that's sodium chloride works in the group very well because chlorine cannot be distilled, and that's why it's very stable. With you can find sodium naturally in salty environments, which are like that's what really affects. Chlorine is used in water purification, disinfection, but because it's like a stable invariant isotope to sodium. Basically, just if you Google these words, you can find the division of everything. Sodium vapor, sodium composition, sodium fire. This the fire. Sodium is repellent, basically. Sodium burns, but it's easy to ignite for them. It's just ignites with the combustion. High restriction can it's polyethylene because it comes with oxygen. But basically, you get water, O8 H2, which is egg in form, but you get the thermal sparse of it. You get modern. If you break away all the hydrogen and oxygen and you find them in the isotopic configurations, hydrogen only. If you put them in two separate chambers, you can literally just form water, but in different ways. So if you have all the chambers, basically, it's basically basically you have say you have chlorine, two elements only. You get sodium in one aspect, but literally sodium in one basically not NCl, not NaCl, but literally the other one. Sodium chloride, because I'm trying to put out fire but with water, but because oxygen is good as well, so it can burn more before it puts out, but it burns more because you can't use water to put it out, and that's used for fires. In the first fire, you never want to use water. People use foam, but foam is still the same thing. It consists of oxygen because it releases oxygen as it does the job. So that's why I don't like foam, because the foam is basically oxygenated before it becomes foam. So it has to get some with oxygen before it works. But you can't do that properly. You have to distill all of that out. To work the way you want it to work, and that's why you never want to put on a naval fire with oxygen, because if you've got an NSIGGI tank nearby and you're doing it in the real world, it's not really practical. But it doesn't matter what you do, the oxygen will still be there, literally, because the oxygen is reacting with the system. Because you breathe oxygen, and you still you have to breathe oxygen at some point. When you work, do that job, pull out a fire for us. What else? Reactivity. Sodium is highly reactive because nice temperatures are low for liquids. Basically, O to the power of 8, O sub 8 H2 is literally oxygen. H2 is oxygen, hydrogen, oxygen building first, breaking and building first, breaking up. If you break oxygen, it doesn't matter how you put the hydrogen. If you break stable hydrogen from oxygen, you get helium. Helium is the same thing. Helium mix helium and helium composition. Helium is what you put in balloons, but that's hydrogen in form. So helium is a noble gas. Second lightest, but it's sodium. Basically, helium can be dangerous because you get helium. You can't see it's colorless, odorless. But even with this one, you have too much of it. It's literally the same nonsense you have when you get hydrogen. But hydrogen is like not what you're gonna breathe in. But you need hydrogen to be molecular. Hydrogen is the chemical. Basically, there's a lot of similarity. For me personally, I'm investigating why helium is hydrogen is really needed, because you get I think you get all the similarities I can measure. Similarly, you get all the sparse ones between hydrogen and helium. They do similar. Why don't we just, for me the question is, why aren't we breathing helium instead of hydrogen? Why are we breathing hydrogen? Why are we breathing hydrogen? I don't know why we're breathing hydrogen. We could just be breathing helium, oxygen. Voices sound less and less. We'll be funny voice. That's what I'm saying. And then we get on laugh at each other. But I don't even know why this happens. But helium is there. We get hydrogen. Two hydrogens equal to one or equal to two heliums. But it shares the same properties as hydrogen, which I'm really annoyed because I want to sound like a clown when I talk to people, and I don't when I'm confident. I just inhale more helium in the air, and that's what I really like. Helium is light, but hydrogen is lighter. Wait, it's Wait, helium is light. No, helium is lighter. Helium is lightest, second lightest. But how light is helium? I don't know. Helium and hydrogen size, mass. Basically, mass of hydrogen. Basically, helium and hydrogen are literally just mass. But I don't want to talk about that really. So basically, you get the sodium chloride and you get that +1, but they always give you an electron because the electron charges just pass by. Because you're just switching literally. the kind of stickiness of the napalm bomb is usually it gives you more stuff to burn. It gives you, it just absorbs more. It gives you less, but it uses more energy, less energy to do more because it just sticks to any surface. That it's contaminating the environment. That's why it gets more. As it goes, one gives one, the other gives you. It's the same. If you catch something, I don't like that analogy because that's it gives you more. I don't know what I mean. More excited matter because I'm thinking of excited matter as the state it's in. For example, if you get a lepton. A lepton is just the same thing as a electron, but electron is like opposite electric charge. So a lepton is a left charge. It's two left charges against an electron. But you need to get that stable. But the thing on stability is like you have to look at it from an angle. Like when you get a lepton, you're looking at one full lepton. You can have one electron, but that one electron is fixed on a plane XYZ. So the plane on the electron is just high. The one wondering why because they have the same composition literally. But it's kind of weird, which I'm claiming they do. Just kind of look different. Because for me, I work with this kind of system, and I'm looking for new definition patterns, silicon NLP, new direct learning protocol. I don't know. So atom numbers 2. Basically, they're strictly different. Oh, I'm wrong. Am I wrong? Basically, this is putting like 1 to 2. Basically, I'm saying there's some kind of hydrogen configuration that is helium. But why do we need to get helium? Helium is I think that's 2, but we get as one. We get basically helium is heavier. Helium is heavier, so we can just basically we can breathe helium. But why does it work that way? Because you can breathe helium. Helium is lighter than air, but why is helium lighter when its mass is bigger? It doesn't make any sense to me. Why isn't hydrogen lighter? No, helium is more. No, helium is not lighter. Look, basically, I've been trying to solve this problem as a child, but it's kind of like a model problem. But they're strictly equivalent. But just very sparse, very different in how they behave, and that's what I'm trying to identify with the lepton Eulerian composition for electron modeling, which is just a charge in space and time. I'm trying to model it properly, but let's just watch the problem. So that's just the napalm shot. Basically, the napalm is like basically the napalm thing was like just the napalm incident with the napalm striker, basically the girl from the so good and sang it, but the film next to the film. But I love that film literally because the napalm strike is sticky. I hate the stickiness, and this is why the Black Ops video matters. So the Black Ops 2 Burning Man scene is just the opening scene, and that's what I'm going to show you guys now. It's because I love it. I love the scene, but it shows real world problems with the secret protocol because people that are Asian not afraid to open up, but people that are American are shut them down. And I'm just trying to make the think about the Asian why they want to speak because if you get hacked or you really get hacked or intercepted, very easy people still communicate and organize themselves. Doesn't matter how hard the stuff gets. It's just like whether someone die or not, they are there now. It's like saying that the Japanese are stronger. They're stronger. They just hold the connection, hold the gut, hold the guts, and mission is to communicate. So if you're hungry, you're gonna die. And you don't communicate, you're gonna die. I'm just saying. That's why the NSIGGI N for November, S for Sarah, I for Indigo, G for Golf, I for India matters so much because that's an obvious because it's just a protocol for like a human sentient procedure. If you talk wrongly, you're really dead. If you send wrong message in anger, fragging, all that kind of things, and that's why the protocol matters. I'm trying to document this properly because this will be done. Okay, this is what the video is. See, look, before the help came, he's already died. Look, he's burning in flames. This is the opening scene from Black Ops 2 on YouTube right now. So he's dying in frame, literally, and that's why it matters. No! So he could have just asked for help, but this guy is locked in. But you can't help him anymore because he's already dead. This is why the NSIGGI program. This is the only why it matters. Over here! Hold on! She's trying to smash her. I'm trying to smash her, or the gameplay. I'm trying to smash this guy, help this guy, but he's dead already because the fire's really off. The napalm was really hit. And the fire's really off him. And he's already just panicking, and he's gonna just die now.
Savimbi, you gotta help! Frank, damn it! The fire finished. That's too late to save that.
Basically, that's why it matters. Because Call of Duty Black Ops 2 reminded of the trauma of the napalm war. But, it's because of the burning. It's because of the issues with the system around human rights. They love money in it. But, human rights articles are really, there's some people with different minds. people who have already been to war. Businessmen, a lot of people that have come together and made human rights, but they were in human rights, but they didn't think about their health cells. If you think about perfectly, if they don't train you for war, then you have the same problem. Then you go back to war when you should go back to war. Whether you're crazy or not is not the problem. It's the state of being that you have to preserve. First, hey Rose, hey Namdi. But literally, it's basically napalm. Napalm is chlorine, but it's sticky, so sticky. It's just like, you don't even know where you have it sometimes. You can ignite, but sponges not burst. If you take a lot of sodium chlorine, you don't know how the sparks conversion works. Because literally, you can be sparks, you can't hear the system talking to you because you're in a state of panic. But you have a lot of chlorine and you just ignite. I get that worse because sponge is combustion because you have two states, sodium and chlorine. You get the combustion, the fuel, but the fuel fuels the fire, fuels the what burns, and it burns out of the system. Basically, you get something that's burning, but it's water, liquid, because it's liquid you cannot drink. That's not I suppose you can distill it is ready, but you have to burn the fuel come out first. But that's kind of the problem here. I'm saying it's why the thing matters really, the NSIGGI protocol, because it's really about human rights really. That's what it is about the policy now. NSIGGI protocol is about human rights only. But it doesn't matter if it's soldiers or war or like that is war tech, because basically it's war tech, but you just say it's war tech because if it's that same category of war, literally if it's in that war because you may be dying or fighting, but you don't know what you're gonna eat next, so you are struggling already. But no one's gonna come to you, so to you to get you onto you because you had that's your mission. That's what really matters. That's what really matters. It really matters to me. It doesn't matter if it's two cups. You can put one right on one go right. Basically, it doesn't matter if you put talking to people, you have to do something about it, and the protocol just does that automatically. It's on the fly, so it should be done. Things that you need should be there. No matter how far you go in war, it's really a protocol for human rights. Because people that are mad don't even know they're mad until they told they're mad, until they get some kind of test. But if you're in the war zone, are you mad? Are you crazy? Are you seeing stuff? It's kind of like the problem with the whole trend function going run up and down in war and trying to get some kind of thing you need and you don't want to go about. It's really there because you need it. It's not because you don't need it. It's because you don't. So the kind of chlorine gas is like topographic because the structure grows with you. So this is like a map of a video of it. So basically, what image is this? So basically, this is energy generation. Basically, this is like a way it goes. Chlorine use, propane gas. Propane gas, guys. Propane. Basically, this relates to propane gas too. I forgot to tell you guys about propane gas is flammable gas. Oh my days! Look, basically, there's a lot of propane gas in this fire thing, but I'm trying to make a grenade of this system. But propane gas is gas that that's flammable. It's just like a very flammable gas. It's like it's very dangerous. Like it just press fuse it and everything just burns everything else. It's literally what's using the fire extinguishers. No, the other one. Basically, get the foam put out. The foam can put out like it's gas, but it's flammable. But you got propane gas in what? The kind of fire. You get like a fire flamethrower. This was a lot of things useful, but this is safe because no matter how much you shoot the flamethrower, it doesn't put out, and it's like a foam, extremely flammable, fire explode hazard, container pressure, carbon monoxide. Monoxide just you see you can go basically you get the monoxide well and you go to the dioxide. Basically, there's two axes to it. You get a monoxide, which is just one. Because it's one reaction, but carbon reactions with oxygen is a monoxide reactant. Because dioxide is stable. Monoxides are never stable because when you emit something in an isotope structure, no, it's unstable because carbon oxygen has to bind to something, and if that oxygen is a reaction, it wants to let go. So the dioxide is what we breathe out. The moisture is what it contains that's flammable, and that's why the propane gas works. Propane is flammable because of the propane gas is monoxide. So you get basically it's unstable. You get carbon monoxide in this kind of system, and that's why it's dangerous. The more you just release. No matter whether they are in a chemical composition or liquid or not, no matter how that's topographically structured for the environment, based on the flamethrower system. But I'm trying to get a kind of water grenade. English kind of water grenade too. So some grenade that literally just implodes before it explodes. But basically it implodes because it has to implode first to cover some area of density to act on that eligibility. You just cause some area. So I'm trying to get the inverse of this flamethrower, because you get an impulse, you just throw a water grenade, but it's a grenade that explodes, but what you have to implode or explode. So it's like a grenade. It was like an M19 grenade, but it's just easy to pour flamethrowers. Just when you check it into a ship, and it implodes the ship, and like basically it's a real life grenade. It's like a grenade that's implode. Just basically, a grenade has to implode on itself, dimensions to cover. It has the areas to cover, and that's how the grenade should work. Basically, if you have a grenade that explodes, it causes a 5 meters radius automatically, a 5 meters radius automatically, but 10 meters radius diameter in the grand scheme of things. So 10 meters of someone's of anybody in that radius is gone. But I'm saying to you guys, because the 5 meter radius is just the default what you gotta get after. But if you don't know that, you're just falling for the death trap. But if I implode my dimension and that's 10 meters. 10 meters of diameter, you already covered that 10 meters or 5 meters already. Someone's then the 5 meters already gone, so you don't know be that 5 meters. So I guess half the dimension of 10 radius. But if it does properly, works properly, and it causes double in shrapnel. But the shrapnel usually implodes before it explodes. It's like a double explosion, really. But it's just basically the half explosion is less powerful. It's more powerful in the range, and the more we just put up water, but it's more water bomb. It's like a water bomb. That's what I call it. It's water bomb. It's really just water bomb. Don't think about it anything else. It's water bomb. Implodes and then explodes literally. It's no matter where you throw it, you can get away from it, because you don't want to throw it and blow up. Because the problem with the M19 is like an M19 grenade. You throw it, you can come back to you if you throw it wrong. But if it implodes, you can have extra time. You sell it, so it's like a timing issue at one. Because if you have a M5, if you have a sizzle, if you have a M5, if you hear it, it's gonna explode, but you're surprised it implodes. So you say you're safe, but you don't know what it is. You don't know what it is. You can make much of the tape because it's sparse now. So you get one that's explode, one but you don't know what you're gonna get. So you just get out there anyway. So it gets people actually won't move, because if you don't move, you are still having a problem there. It doesn't matter how flexible the person is. That's what I'm saying. If you lose half your dimension or space you're firing from, you're gonna wonder where I'm gonna go cover next, because it's just second down those seconds you get. That's what it matters. Because if you implode, you have to basically my grenade can literally just implode, because it has to get people out of there. Out of the same. Because if you implode something, you have to explode it too. Because you lose the dimension to explode. It has to implode. It uses less energy to implode. But it's half a dimension to scale, to double the dimension. So you have 10 dimensions covered, and you have a double dimension of the radius. So you get double the radius in the force, basically in the force, and that's really shrapnel. But you get 5 radius covered already, because that's already implosion, and then double of the 5 radius will be what 5 squared in the radius in the diameter. That would be 25 over 2. That would be 12.5 radius. So it'll not be 10 radius, but 12.5 radius of the region, whatever the system was, or meters it covers. Just by getting water bombed. Literally, that's what I'm thinking of. Because it matters to me, the secret project. It doesn't matter what it's water or no. It's basically finding solutions to real world problems, and that's what the protocol really is about. Whether someone that is war novels in the Harvard, that's a real objective. You don't have to be war aligned, you just have to be knowledgeable enough to use things. No, that's what I'm saying. It's that's the goal there. Okay, thank you, Namdi. Continue with your project, and please try to update the channel. We're kind of tired now. Today's time's now 5:58, 3:58, 27th of December 2025. Thank you. Let's continue. Because I don't like this man. I don't like someone who's trying to get.